All right, so we have a rectangular page is to contain 30 square inches of print. So that means you are given the area. Okay, so that's 30 square inches. The margin of each side is 1 inch. So that means we have this part right here. Okay, and so we have what? We have the width, we have the length. Okay, so we want to find out the dimensions of the page such that the least amount of paper is used. Okay, so how do we set up this equation? Well, the first thing is to find out how we can describe the big length and big area. So we can say, wait, hold on. Actually, no, my bad. This should be 30 square inches of print. So this would be 30 square inches. And then the margin of each side is 1 inch, and we want to find out the actual dimension. So that means W plus 2 times L plus 2, it's equal to 30. Okay. All right. And then what? Well, we want to find out the least amount of paper that's used. So what we want to do is to find out, we have to have an equation with just these. Now, of course, our trouble is that we have two variables. We have two variables. Oh, no, hold on, my bad. That's A, sorry, that's not 30. W times L is 30. Okay, so the print area, which is width times length, it's 30. But if you include the 2-inch margin, that would be the actual dimension of the page. So we are going to find a derivative because we want to find out where A prime is going to be equal to 0. Dilemma. What's the dilemma right here? We got two variables. And we say, that's no bueno. So how can we not have two variables for this function A? Well, then we say, well, you know what? We can always use the given information because width times length is equal to 30. So I can either solve for L or solve for W so that I can substitute in. And I can do my FOIL. Okay. So so I would need to FOIL, so it'd be 30, and then plus 60 over W, plus 2W, plus 4. Okay. And if I do the A prime right here, the 30 and the 4 would just go away. So I've got myself negative 60 over W squared. Okay. All right. And then we say what? We say, yeah, so we need to set this equal to 0 because we want to find out where the maximum or minimum is. And we say, yeah, negative 60 or 60 over W squared is equal to 2. So W squared is equal to 30. So W is going to be square root of 30. Okay. So to use the least amount of the paper, so W times L would be 30. So L would have to be also a square root of 30 as well. Okay. All right. So that's how you optimize something. You always set the prime equal the derivative equal to 0. Now, of course, one thing that should concern you is how do you know it's a minimum? I think that's a very good question. How do you know it's a minimum? Now, so square root of 30 is definitely our critical value. So let's think about this, okay? If W it's greater than smaller than square root of 30, okay, then you have a negative number on the first term that it's bigger than 2, and then plus 2, so that results in a negative. If you have a W that it's bigger than root 30, then the first term, the negative term, will be less than 2, and then plus 2, that will become a positive. So in terms of slope, it goes from negative to positive. So that's how we know that it is a local minimum. Okay, it's a local minimum on the actual area function. Good.